Hi, and welcome to this PowerShell tutorial video. In this video, we're going to be looking at running scripts in parallel. So Microsoft has made it quite a lot easier to run tasks concurrently or in parallel, you can call it as well, with PowerShell 7. Now, you've been able to do this since PowerShell version 2, I believe, but it was always involving quite a lot of work, either creating workflows or creating run spaces. And then in PowerShell 6, you were able to do start-bread jobs, but then always had to remember to also remove them. So with PowerShell 7, they've added a really cool parameter on the ForEach-Object. It will not work if you only type ForEach, but if you do type in ForEach-Object, you are able to add the parameter of parallel, and it will only take in input from a pipeline. So we're going to be taking a look at that today to see when you should be using it and what type of benefits does it bring you, and where cases that you should not be using it because it's just strictly going to take more time because of the increased overhead of creating those run spaces in the background. So let's go ahead and let's just start to see how we can actually run in parallel here. So I'm going to create a array here. I'm just going to do $array, and I'm going to make my array just equal 1 to 10. So this is like a short form of creating an array from numbers 1 to 10. So if I just run this here, and then we look at what is inside of array, we have numbers 1 through 10. Perfect. So then what we're going to want to go ahead and do is we are going to want to go ahead and loop through this array. So typically, what we could do is we could do array, and then we pipe this into a for each or a for each object. We're going to do for each object right away. And then we could do an open and close curly bracket. And then we could do a write output $_ to take in the input from the pipeline. So let's run this here. And we are going to see that it simply just prints out 1 through 10. And then to see that a little bit more visually, what we can do is just add the word I'm in front of it. So there it is. I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what we could do is we can add, at this point, our parameter, which is just called parallel. And then if we run this again, it would help if I spelt it correctly. So there we are. So now we can see that, so I'm just going to expand this out a little bit just because this is one of the first main points. So without the parallel parameter, we can see that we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now when we add the parallel parameter, we get 2, 1, 3, 5, 6, 7, 4, 8, 9, 10. And this is because each time we're just creating a thread, and we don't care about in which order they print out. We are just telling PowerShell that we want to run all these options from the array in parallel as fast as you can, and then the computer then organizes all the threads per the amount of cores that you have on your computer. Now, this doesn't mean that if you just have like an 8-core processor, it will only run 8 times. There are logical processors. So usually in a 2-core system, you would have about 4 logical processors. In a 4-core system, you would usually have about 8. Now, this could vary per system, and also if you're running it on a server or not. So it would really depend on the type of processor you have and whether or not it is a server or just a workstation. But also you can run multiple threads on one core. It'll just block itself and then take turns, and then in fact seemingly look like it's running concurrently. I'm not sure if that's 100% clear or not, but this is how you would run things in parallel. Now let's see the performance difference from the two. So if we do a measure command here in front of these arrays, so in front of these write outputs, so we're going to do one with parallel. So let's just see what this takes. So currently to run this through an array of 10, it is taking 112 milliseconds with the parallel parameter. Without the parallel parameter, it is taking 18 milliseconds. So we can already see that in a case where we're just printing, parallel isn't faster. And we can actually make this a lot worse is if we have 1,000 entries in our array, if we are just running them serially, so one after another, it is taking 58 milliseconds. If we add the parallel parameter, it is going to take us 2 whole seconds and 422 milliseconds. So much, much longer. And this is because when PowerShell gets the ForEach-Object parallel, it will start up a run space and then run the inside of that ForEach-Object loop in another thread. And it does that multiple times over, increasing memory usage, increasing like the processing power that your computer is currently using. And might not necessarily be faster because it takes time to spin up those run spaces compared to just printing an IM and then a number. Now, in cases that this will be useful, because of course I'm not going to show you guys just where it's not useful, but definitely one of the cases where it's not useful is if you're just simply printing to a screen or doing very, very basic tasks, or if you are running a VM with only one core. The parallel keyword will not do any difference because you only have one core. You'll probably actually just make the performance a lot worse because you're spinning up all these different run spaces and causing a lot of blocking in those threads. So it taking a lot more time because at that point, then to complete one of the threads, it'll be limited because it's got less resources now to complete that one instead of going serially where it could dedicate all of its power to one at a time, making it faster. Now, one of the times where it will be much faster is if you have something that needs a waiting period. Now, we can simulate this. So this would be something like an API call or another commandlet like getting the event logs, which we'll actually take a look at in this video as well to see what the performance differences are. So we can actually simulate this by doing, we're going to just put in as the first output, we're going to do entering and then the number. And then we're going to do a start sleep. And we are going to start sleep for 1 second. And then we're going to do the write output. And we're just going to do exiting and then our number. Now what I'm going to do is I'm going to take away the measure command for now because I just want to show you guys how this actually executes. And you guys will see how the threads are actually entering and exiting. So here we have just an array of 15 just to make it go a little bit faster. So let's see what this does. All right, so here we have entering 1, 2, 3, 4, and 5. And it exits out of 1 and 2. So it creates 2 more threads at 6 and 7. It finishes the third thread. So it then starts number 8. And then it exits. So this one we can see that it's only using 5 threads, which is perfectly fine. But you can actually modify this using the throttle limit. So if I do the throttle limit of 3, we are going to see that it is only starting 3 jobs at any time. So it will not run more than 3 threads at a time. And we can change this to 4. And then we will see also the other difference. So here we are, we have it at 4. So the first, it starts up the 4 threads, it exits out of number 1. So it starts up another one for 5, exits out of number 2. So it starts up the next one for number 6. So as you can see, you can really control this. So if you do not want it to take so many cores to not jam up your computer resources very, very quickly, you could do it this way. And we can even do a throttle limit of 10. So there we are. It shows up through 10 and then it starts finishing and then it does some more as well. So let's see how this actually turns out if I take away the throttle limit for now and I do a measure command. So now we have our measure command with our parallel command here. So let's see how long this takes to run. So we have 15 elements in our array and we are sleeping for 1 second for each. But we see that the actual whole command only takes just under 4 seconds to just over 3 seconds to run. So 3 seconds and 93 milliseconds. So pretty much 3 seconds there. Now, if we actually remove this parallel keyword and we run this, we will see that it takes much, much longer because it's got to execute each one and it's got to wait 1 second each time. So in here, we can actually see where the benefits are of using this ForEach-Object parallel commandlet. It's going to be in scenarios where there's a lot of waiting involved. Now we simulated the waiting with a start sleep commandlet, but we're going to simulate it now with a get win event. Now this is not going to be as extreme because we're only playing with one computer and we're only going to be doing maybe 3 or 4 event logs. But this could definitely get quite expansive if your process takes, let's say, 5 minutes to execute. You're doing some API calls. You're going to be doing some stuff with that data. And all in all, that script for each one normally takes about 5 minutes. And you have 5 of those. So you have 5 times 5 minutes. If you're running those, it's 25 minutes. If you have 10 of those, it jumps up to 50 minutes. But if you had a ForEach-Object parallel and you executed that task with a throttle limit of, let's say, 5, it's going to be running 5 of those at a time. It's only going to take about 5 minutes, give or take, maybe a little bit more, maybe a little bit more because of the creation of the run spaces. But that's what it would really end up taking. It would launch the 5 threads that each take about 5 minutes, but they're all running at the same time, meaning that it'll only take 5 minutes. And if you have 10, it'll only take 10 minutes compared to the 50 minutes. So those could definitely get some exponential savings when you're dealing with numbers like that. These numbers are quite small because we were just talking about a 1 second waiting period. But let's go ahead and let's take a look at a collection of logs. So with the event viewer. So what we're going to want to do is let's go ahead and let's just take away all these variables here. And we're going to be looking in just a few of the logs. So we're going to create an array called log names, and we're going to create this as security application. Then in for the next one, we're going to do Windows PowerShell, and then we're going to look up the DNS server logs as well. So here we have all of our log names. So let's go ahead and let's do log names, and we're going to pipe this to ForEach-Object. And let's just do the regular ForEach-Object at first. So then what we're going to do is we're going to do events equals get win event for the log name, and then we're going to pass in our log name here. Again, it's just the $_ because we are taking it from the piping of log names. And we're going to do max events. Let's get 5,000. Actually, let's get 10,000 events at most. And then what we're going to do is Yeah, so that's all we're going to do for right now. We're just going to simply collect those events and see how long it takes without the measure command, just to see for fun how long it takes. So here we have it. It's taking a little bit of time. We've seen this get win event before in a previous video, and I've showed you guys how to make it a little bit faster with the filters with XML. But I am purposely just making it take a little bit longer here. All right, so it took a decent amount of time. So what we're going to go ahead and do is we are going to do a measure command. We're going to open that there, and we're going to close that. All right, so let's see how long it takes. Again, this is not running in parallel. So let's see the results here. And this should take, so this takes about 10 seconds. So it's not bad. It's not super fast, but it's not super long. Now, if we add the parallel keyword to this, and we run this now, we can see that this took only 8 seconds and 344 milliseconds. So a 2-second difference on just collecting a very, very small amount of data. This computer does not have a lot of events in the logs, so it's not a great amount. But you can definitely see, and if we were collecting these from remote computers or doing other things with these events, it would definitely be a lot more time saving. And I mean, 2 seconds, if we extrapolate that throughout like an entire day, it could be quite long depending on how often you are running these commands. Now, what if we wanted to store these events into a array? Now, this is where the for each parallel does make it a little bit more difficult because you cannot access outside variables. Very similar to PowerShell remoting. When it creates a run space, it is a isolated thread, so it cannot access the state or variables of other threads. So what we need to do in order to be able to store these events, so what we would typically do is we would have a export variable here, and we would typically create it as a system dot collections dot array list, and create that as a array list here. And then what we would typically do is do export dot add, and then events, and then we would print out the export. So if we actually try this here, we actually get an error because we cannot call a method on a null valued expression. Now, and this is on the line 3 export.add events. Now it's determining that export is actually null, which we know it isn't because we have the array list here. But because of the for each parallel in the thread that this is running, export does not actually exist yet. So in order to import this variable, very similar to how we did the PowerShell remoting, we need to use a keyword. So what I like to do is I like to recreate the variable in here called export, and we're going to create that, and then we're going to make that equal to $using, and we're going to do a colon and then export. So what this is telling it, it is using export from the original script here, the external value, the variable externally here. So what we can do is we can then go ahead and run this and see what happens. We can see that we don't get the errors. And then when we go to print out our export at the end, we will actually see that it does print out all the events. So everything works properly. So that is a little bit of a gotcha there in the for each object if you are planning on doing some log collecting in order to bring it back into your script later on. And all you really want to do is collect them all in parallel so your script goes a lot faster. But then you want to manipulate them later in another area this is the way that you would want to do it. Now, there is one thing, is that this array list here is actually not thread safe. So you might get errors saying that it cannot write to that array list because it is currently blocked by another process. So in order to actually facilitate using an array list, you have to make sure that it is synchronized. And I'm going to put a link in the description down below kind of explaining what synchronized is. It just makes sure that it is a thread safe version of the array list so it doesn't get blocked by any threads. So what we're going to want to do is we're going to want to do the same thing. Our export is going to be equal to system.collections.arraylist. Then we're going to do a colon, and then we're going to do synchronized, open parenthesis, and then it's going to be a new object, system.collections.arraylist, and then close parenthesis and close parenthesis. So now if we run this, we're going to see that it looks exactly the same. But in the background, this is a thread safe array list, making it sure that we are not going to encounter any issues within our for loop for this array list. So that is really, really important to note, is that any variable like a dictionary or a hash table or array list, and you are modifying it within your for each object parallel or through thread jobs, you are always going to want to make sure that you are using a synchronized table or synchronized list or synchronized hash table to make sure that everything stays intact and you are not causing yourself potentially problems down the line of missing values in those variables because of a lock that had happened. And again, I'm going to be putting something in the description down below, which is an article from Microsoft that just describes the synchronized array list for you guys as well. So now there is one other gotcha, and that is if you were wanting to use a function. Now, to use functions within a for each object, it is a little bit trickier. So what I'm going to do is I'm going to go ahead and I'm going to create a function up here. And we're just going to go ahead and call it say hello. And we're going to do an open and close bracket here. And all we are going to do is do a write output. And we are just going to say hello. All right, and then what we're going to want to do is we are going to have a array here, and we're going to make it equal to just an array of 5. And we're going to do array. We're going to pipe that to for each object, and we're going to pass it in parallel. And what we're going to do is we're going to do a say hello. So in theory, what we should see here is we should see the output of hello 5 times. So if we run this here, we actually get an error saying that the say hello is not recognized as a name of a commandlet or function. And that is because, once again, it cannot access outside of this. This function is not declared inside of the thread of the for each object. So what we actually need to do is we need to create that connection for that function. So what we're going to want to go ahead and do is first create a function definition outside here. So we're going to just create it as a func def variable here. And we're going to make that equal to function colon. And we're going to call this to, we're going to have to reference our function, which is say hello. And we're going to cast that to toString and open and close parentheses. Then inside of the for each loop, what we're going to come and do is we're going to do another function colon, and we are going to call it the say hello function. And we are going to make it equal to using, and we have to use our function definition here. And then what we can do is we can then call the say hello function. So if we run this, we actually do see the hello 5 times. So we do see that it is working. So there are definitely some tricky parts to the for each object parallel, especially when you want to incorporate some external functions or some external variables within that for each object. If it is a fully self-contained for each object, like it's just going through the data, making some API calls, and then performing some action on the system, it's probably a best case scenario. You're not going to really have to do any extra work to bring in something. But if you do have some logging involved where you are logging to a log variable that will get exported at the end of your script, in that case, you will need to do a little bit of that work of using the using keyword. So I would always just make sure that if you are referencing something externally, make sure you just have those connections made. Or try to always, if you're using the for each object parallel, try to keep it all self-contained. And this way you don't really have to worry about that. But of course, there are some scenarios where that cannot happen, but that'll be okay. So that would be really the main part of for each object with the parallel keyword. Now, I actually have some examples where we might think that the parallel keyword is going to be very useful, but it actually turns out to not be useful. So I'm actually just going to paste these examples in here. So what we've had in the last video was a CSV, some CSV files that we were going through, adding the sum, and then pumping them out to the display. And actually this, you would think that it would benefit from the parallel keyword, but it actually does not. So here's our script from last time. Let's do it without the parallel keyword at first. So we're just grabbing the CSV files and then we're grabbing the data and we are outputting the total. So let's just see what it looks like without the parallel keyword. And if we run it without the parallel keyword with the measure command, we can actually see it only takes 16 milliseconds, which is really, really fast. And then we can add the parallel keyword here. And if we measure the command here now, we see that it's 50 milliseconds. So it is actually quite significantly slower, almost twice as slow, almost 3 times as slow compared to running it serially. So what I always recommend is if you have a script that is running slow in serial, maybe try to run it in parallel, see if you get that performance increase that you want. But in a lot of cases, running as parallel will probably not make things faster if the script is already pretty fast. If you are running things on a single core or single CPU VM, definitely would advise against running in parallel as it will not have any benefit to you at all. If it's very simple tasks like printing or reading data, I would say it's probably going to be slower to do a parallel for each object because of the amount of time and the amount of resources it takes to create those run spaces. But if you encounter situations where it's a very time-intensive task, like getting event logs, maybe filtering them a little bit further. We've seen some examples in the other videos of getting event logs taking quite a bit of time. Sometimes a get event log could take 2 to 3 minutes. So if you did have 5 of those logs that you were getting that are taking 2 to 3 minutes each, in that case, you would have a big benefit of using the parallel keyword with the for each object. So it's really just to know when and where to use the parallel keyword or the parallel parameter on the for each object. It is very tempting to do it for everything, but there's actually a lot of situations where the parallel parameter is actually not beneficial. Another example that I can give would be a Active Directory user creation. It might actually seem like it is a lot faster if you were to run it in parallel, but I actually have an example here. So let me just copy this example in here that we have. So we have a CSV file that I have here with 5 different accounts, and that's just 5 accounts. So we import the CSV file and we create a AD user for each of those lines. So let's actually see how long. Let me just make sure that these users actually are not still in my Active Directory, which they actually are. So let me just delete these users here before we do our test. And let's do the measure command. So this is running not in parallel. So this is running in serial, creating one at a time. So let's see what happens. Oh, and actually that will not work because I did not put in the correct folder name. So let's run this again here. So let's just make sure the users got created, which they did. So we can see that it only took 381 milliseconds to create these users. So not very long at all. So if we actually delete these users once again, and then we run the task as parallel here. So we can already see that it's actually already taking a longer time. And now when we look at the time, it actually took 5 seconds and 697 milliseconds. So that's almost an increase by about 6 times the amount of time. Actually, I think it's a lot more than 6 times. It's a lot more because if I look at the milliseconds, it is 5,697 compared to 381. So that is about like, I would say, let me actually just get out a calculator here. So that is 5,900, 697 divided by 381. So it is actually almost 15 times slower running it in parallel because the actual command of new AD user does not take a lot of time or a lot of processing power. The computer is not waiting on Active Directory to then go on to the next one. It will actually create that new AD user, send that command, and it's already on to the next one. Whereas right now, it's creating the run space. It is creating this hash table, sending the new AD user, sending that off, and then doing that for each one. So it has to create 5 run spaces, where it just doesn't really need to in this situation. Another situation where actually AD user, I would actually advise against doing parallel is if we remember our script where we've automated users, we were checking at the time to see if the username already was existing. Now, if you're having 5 threads going at once, you might encounter the situation where that script tries to create a user with the same username because the first time when it checked, it didn't have a user there, but then one of the threads, so you'll have your 2 threads creating a Smith. One person's name is John Smith, and the other person's name is Jane Smith. And they both look at Active Directory to go see if username Smith J is existing. But both of them haven't executed the new AD user command, so they'll both get that the Smith J is available to use. And once it actually pipes that into the new AD user, you will actually get 2 AD users that are going to try to get created as Smith J, which one of them is going to error out. And potentially you might miss that, or it'll cause an error in the script, and then you'll have to go back and fix it, creating more of a time loss. And we've already seen that the for each parallel already runs a little bit slower. So in all, this would just be a very, very bad way to use the for each object parallel. So the two cases where, again, that I would use it the most would be API calls and event viewers. Of course, there are a lot of other options that you can do with the for each object parallel that I did not mention here. Always the best way to see if it would benefit your situation is to test it out with the measure command and see if there is any benefit. And if there is a benefit, then use it. But just be aware that you should not be using it for every scenario, as it is not beneficial in every scenario. So I hope that helped you guys with the for each object parallel commandlet. I might have repeated some information over and over again, but I just want to be sure, because this is quite a topic that even I struggled with quite a bit to learn in the past. Knowing that why is it not beneficial in every situation, I figured that it would always be faster to run things in parallel, but then learning that that is not always the case, and with this measure command it really kind of shows you how that works. So if you guys have any questions or comments, leave them down below in the comments section and I will get back to you. If you guys have any questions and want to see a video on that topic, let me know down below in the comments section as well. Hit like and subscribe and hit that notification bell to be notified when that next video comes out, and I will see you guys on the next video.